Back in 1964, Japan changed the world by turning the high-speed rail into a national icon. But now, half a century later, the same pioneers behind the bullet train are digging a massive tunnel through the Southern Alps. They are building something that feels less like a train and more like a jet flying at zero altitude. It floats. It uses magnets cooled to negative 269 degrees Celsius, and it cruises at 500 kilometers an hour. But just across the ocean, China wasn't content to just watch. They are building a tube, sucking the air out of it, and aiming to beat commercial jets at 1,000 kilometers per hour. Their rivalry has created trains the rest of the world can't ignore. While Western countries are canceling their projects, Asia's going all in. This is the story of how Japan's 500 km per hour tunnel train and China's 1,000 km per hour vacuum train ended up in a race to kill short-haul flights, and what that means for the rest of us. To understand why this race matters, you have to look at the problem with the trains we have right now. For nearly 2 centuries, we've relied on steel wheels rolling on steel rails. It's a great system, but it hits a physical wall. Once you get past 320 or 350 kilometers per hour, the physics start to fight back. The wear and tear gets expensive, the noise gets unbearable, and the ride gets shaky. This creates a frustrating gap. If you want to travel about 800 kilometers like from Tokyo to Osaka or Beijing to Shanghai, you're stuck. The train takes just long enough to be annoying, but the plane is even worse. We all know the pain of modern air travel. By the time you travel to the airport, take your shoes off for security, wait at the gate, and taxi to the runway, a 2-hour flight effectively consumes 4 to 5 hours of your day. That friction is exactly what Japan and China are trying to fix. They aren't just building faster trains, they're trying to break this cycle. They want to compete directly with airlines. The goal is to turn massive regions into single economic zones, where you can live in one city and work in another hundreds of kilometers away, as easily as taking a subway. But once you decide you want to beat a plane door to door, you can't use wheels anymore. That is where magnetic levitation comes in. Let's get the basics down. Maglev stands for magnetic levitation. The concept is simple. You use powerful magnets to lift the train off the track, so there is zero physical contact. Then, use motors to push and pull the train forward using magnetic fields. Because there are no wheels and no friction, the ride is incredibly smooth. But getting rid of the ground friction reveals a new, much tougher enemy, the air. At 500 or 600 kilometers per hour, the air behaves like a solid wall. The drag rises much faster than your speed. Pushing through that air requires a massive amount of energy. This leaves engineers with 2 choices. Option A, you keep the air, but you build a train so powerful and a track so straight you can brute force your way through it. Or option B, you don't fight the air at all, you get rid of it. Japan chose option A because of earthquake safety, cost, and noise. China, as we'll see, is betting on option B because vacuum requires maintaining a 100+ kilometer tubular seal. Both chose mathematically viable but different paths. Let's start with the side of the race that is currently pouring concrete. Japan is building the Chuo Shinkansen. It's a massive physical construction project linking Tokyo, Nagoya, and eventually Osaka. The goal is to run commercial services at 500 kilometers an hour. To put that in perspective, the trip from Tokyo to Nagoya, which currently takes under 2 hours, will drop to 40 minutes, and it will get you to Osaka in around 67 minutes, compared to 2.5 hours on the current bullet train. The technology here is purely Japanese. While other maglevs use standard electromagnets, Japan uses superconducting maglev, or SC maglev. The magnets on the train are cooled with liquid helium to negative 269 degrees Celsius. At that temperature, electricity flows with zero resistance, creating incredibly powerful magnetic fields. This power allows the train to float a full 10 centimeters, about 4 inches, above the track. That 10-centimeter gap is a game changer. Japan sits on the Ring of Fire, where earthquakes are evident. A tiny gap of a few millimeters would be dangerous during a tremor. But 10 centimeters gives the train a safety buffer, keeping it stable even if the ground moves. But achieving this safety and speed has come at a crazy cost. In early 2024, it was revealed that the project price tag had ballooned to over 11 trillion yen, with total costs estimated higher. That's roughly 72 billion US dollars. Why is it so expensive? Because the train almost never sees the sun. About 86% of the Tokyo-Nagoya line is inside tunnels. To go 500 kilometers an hour, you can't have tight turns. You have to blast a straight line through everything, including the Southern Alps. They're digging deep, up to 1,400 meters below the mountains. Going underground solves a lot of problems: no noise complaints, no weather delays, and better earthquake protection. But it caused a massive political headache. For years, the project was stuck because of a standoff with the Shizuoka prefecture. Local farmers were terrified that tunneling under the mountains would drain the water they needed for their tea plantations. This dispute alone pushed the opening date from 2027 deep into the 2030s. So why stick with a project that is years late and billions over budget? Because for Japan, it's not just about speed, it's about survival. Japan is terrified of the Nankai-Trao earthquake. If that megaquake hits, the existing bullet train line could be destroyed, cutting the country's economic arteries. This new line is essentially a hard drive for the Japanese economy. Buried deep underground, it is designed to survive the catastrophe that knocks out the rest of the country. But while Japan is focused on making the first 500 km/h commercial line a reality, China is aiming at something far more extreme. China didn't start from scratch. They've been operating the Shanghai Maglev since 2004. It's capable of hitting 431 km/h every day, giving Chinese engineers 2 decades of real-world data that no one else has. But they reached a conclusion that fighting the air at those speeds is inefficient. They realized that pushing a train past 600 km/h in open air consumes way too much electricity and creates shock waves that can damage the track. So the Chinese state-owned aerospace giant CASIC decided to bring the space down to the ground. This is the T-Flight project. The concept is to build a sealed tube around the track and pump the air out, lowering the pressure to about roughly 10% of sea level atmosphere. If you do that, the drag virtually disappears. Suddenly, 1,000 km/h isn't physically impossible, it's efficient. Inside the tube, the pod glides on a magnetic cushion with almost nothing to slow it down. This isn't just theory anymore. In early 2024, at a facility in Datong, a CASIC prototype hit 623 km/h in a low vacuum tube test. They're building test tracks with tolerances measured in millimeters. They want a full-scale demo soon, with dreams of a commercial line that could make a train from Beijing to Shanghai faster than a jet. But let's be real, the engineering challenges here are terrifying. You have to maintain a near vacuum over thousands of kilometers. What happens if a seal breaks? What happens if there is an emergency and passengers are trapped in a low-pressure tube? Japan is battling geology. China is battling the fundamental difficulty of maintaining a space-like environment on Earth. But who is actually winning this race? If we look at operational reality, Japan is ahead. They have tunnels. They are digging stations under Tokyo right now. They reached 603 km/h in manned tests. They are solving the boring, difficult problems of making this a real business. China, on the other hand, leads in ambition. They are pushing the edge physics. They are the ones building the hardware for the vacuum tube future that Western tech billionaires only tweeted about. The endgame for Japan is to kill domestic air travel. Once the Chuo Shinkansen line opens, flying between Tokyo and Osaka will make zero sense. China's vision is even bigger. If they can make the vacuum train safe, they could disrupt not just domestic travel, but the entire global aviation industry. There's also a commercial angle. Japan desperately wanted to sell this SC Maglev tech to the US for a line between Washington, D.C. and New York, but that project has stalled due to cost and lack of government support. China views their maglev tech as a future flagship for the Belt and Road Initiative. If they can make it work, it becomes the ultimate symbol of Chinese technological superiority to export to the world. Now, do you remember the Hyperloop? A few years ago, startups in the US and Europe promised us pods and tubes, but fast forward to today, and the Hyperloop has mostly faced a harsh reality check. Massive costs, regulatory hurdles, and land rights killed those projects. Even Germany, which invented the maglev tech used in Shanghai, gave up on building a line at home. Europe decided to stick with standard high-speed rail, focusing on connecting existing networks rather than building new, incompatible ones. Japan and China are the last ones standing because they are the only ones with a specific combination of 3 things: huge populations, central governments willing to fund 50-year projects, and a deep national pride in engineering. In much of the world, maglev is still an impressive demo at an expo, not a network anyone commutes on. So we are left with two giants taking two very different paths. Japan is carving a 500 km/h artery under its mountains. China is building test tubes for a 1,000 km/h train that barely feels the air. Without this race, we probably wouldn't be seeing either of these. Competition is literally speeding up the future. It has created machines that the world can't ignore, simply because they are redefining what distance means. It leaves us with one question. If you could only pick one for your own country, a reliable 500 km/h tunnel train you can ride this decade, or a 1,000 km/h vacuum train that might replace planes forever, which would you choose? Let us know in the comments below. Like this video, share it with your friends, and subscribe to Mega Build for more such videos. Thanks for watching.